Let's look at the propagation and summation of ePSP and iPSP whenever they are produced together and give rise to a compound PSP that we saw on the first slide. We will proceed step by step. At point 1 here is a glutamatergic synapse, and we record an ePSP of a certain amplitude. At point 3 in the soma, we record in current clamp mode the ePSP once it had propagated along the dendritic branch, which is of much smaller amplitude and slower rise time. Now we have a synapse which is GABAergic at point 2. If we record it at point 1, because the propagation can go upstream, we have nearly no change of membrane potential because it is far away. If we record quite close here at the somatic point, 3, we get a small hyperpolarization of the membrane. Now, if the two synapses are active so that they arrive at the same time at point 3, here it's in green. Though the ePSP has quite a large amplitude at point 1, when it arrives at point 3, it's nearly null. So the sum here of ePSP and iPSP gives no change of membrane potential. Suppose now that the two synapses, the glutamatergic one and the GABAergic one, are on the same dendritic branch. Look at the glutamatergic one first. So we record here at the point of initiation, and we have an ePSP here of a certain amplitude. At point 2, this ePSP is smaller because of the decremental propagation, and at point 3, it's even smaller, again, because of the decremental passive propagation of the plus charges. Now, if the GABAergic synapse, which is also on the same dendrite, at point 2, its point of initiation, we see a small hyperpolarization. Once it propagated to point 1, it's of course of much smaller amplitude, and propagated to point 3, nearly nothing. It does not exist. If the two are active nearly at the same time, we see here the corresponding recording. So let's suppose the one here is active first, so there is no change of ePSP, is active first alone. Then it arrives at point 2 when the GABAergic synapse is active. So the two sum, and there is a large reduction of the ePSP. So now when this ePSP propagates to the soma, it's nearly nothing. So from a small ePSP, when the synapse is downstream, the glutamatergic one, the GABAergic synapse, which is downstream the glutamatergic one, is active, it cancels the ePSP. This is a sort of nonlinear summation because of the change of membrane potential in point 2, that the ePSP is much smaller. We previously studied in chapter 5 that sometimes GABAergic synapses have no effect because the membrane potential equals the equilibrium potential of chloride ions. Let's suppose this is the case here. We have a glutamatergic synapse on a dendritic point 1, and it gives an ePSP here of a certain amplitude. Once propagated alone down to the soma, the amplitude is reduced. Suppose now that the GABAergic synapses that we put here at somatic location 2 are active alone. They have nearly no effect because the soma is exactly at the equilibrium potential of chloride ions. So no effect, no change of potential. So of course, when propagated upstream, there is absolutely no change of potential in the dendrite. Now, suppose that the two types of synapses are active in this way, that when the ePSP arrives at the soma, that time the GABAergic synapses are active. We will get this recording of ePSP, a very small ePSP. And you see here, it's not the linear summation of the EPSP plus here the silent inhibition, no IPSP. Why? This is called the shunting effect. The shunting effect is this one. When you open a lot of GABA-A channels. So when a lot of GABA-A channels open, of course, the membrane resistance decreases because there are a lot of channels open. So there is a lot of ions going through, so the membrane resistance decreases. We could see also that the conductance increases. With Ohm's law, we have that if we have a change in current, let's suppose here glutamatergic current, this will give a change of potential, which is here the EPSP. If the membrane resistance decreases, of course, the EPSP amplitude decreases, though the current is the same. So it means that even though here we have the same amplitude of EPSP, when it arrives at the soma, where here the somatic membrane has a decreased resistance, the EPSP is much smaller. So this shunting effect is always present. Why we speak about it only with GABAergic synapses? Because of course when you open any channel, you have a decrease in resistance. But it's more important with GABAergic synapses because they have a tendency to be grouped at the soma here or very near the axon initial segment, where they have, of course, if they are grouped, they have a much bigger effect on membrane resistance.